Okay, this video is to help walk you guys through the homework assignment that we had. The equations that we would need for this one are going to be the speed of sound equals 331 plus 0.6 times the temperature in Celsius, and the velocity equals the distance over the time. Now for the first problem, it asks us, what are the speeds of sound at 10 and 30 degrees Celsius? So it's going to just be using this equation right here. You plug in a 10 for the TC. 10 times 0.6 is going to be 6. 331 plus 6 is going to be 337 meters per second at 10 degrees Celsius. At the 30, you would take the 30 times 0.6, and then you would end up with 18 here. 331 plus 18 it's going to be 349 meters per second at 30 degrees Celsius. Now, beyond that, it says, will the pitch of the tuning force increase or decrease as this happens? Well, it's going to come down to this. The tuning fork is going to set how long the wavelength will be that comes off of it. If we are modifying the speed of sound, yet leaving the wavelength the same, an increase in temperature would result in an increase in speed. Increased speed with a constant wavelength means that if the velocity increases, the frequency would also increase. All right. Now, for the second one, you sit in the bleachers at PNC Park, the first row back behind the 410 sign. The 410 feet equals 125 meters. You see a ball hit 0.36 seconds before you hear the crack of the bat. What is the temperature of the ballpark on this day? Now on this one, we're going to have to use this method here to find velocity prior to bringing it over to this equation. So the velocity of sound on this day equals the distance that sound travels divided by the amount of time it took, which in this case here is 0.36 of a second. Once you have found this velocity, you plug that velocity right in here. All right, so once that is plugged in here, you subtract your 331, you divide by 0.6 to get your answer. To give you guys a little bit better of a chance to turn this in for points, I'm not going to go through every single step of the problem. And for the third one, you stand 100 meters from a radio tower that's struck by lightning. If it's 18 degrees Celsius outside, how much of a time delay would there be between seeing the strike and hearing the thunder? So the only two things I'm given here is that the temperature is 18 degrees Celsius and that the distance is 100 meters. The trick to these problems is to find velocity and find it as quick as you can. In this case here, if I wanted the velocity through this means, I would need to know the distance and the time, which I had here. So that pulled me into this case here. I only know the distance, so this equation's not going to help me off the bat. To get the speed of sound, all I need is the temperature in Celsius. So I could go the speed of sound equals 331 plus 0.6 times the temperature in Celsius, which will give me a speed. Now, from that speed, once I know that speed will go into the other equation. The most common mistake I had on this homework assignment was people taking and just dividing this number by the 100 to try to get an answer. But it turns out that if we're trying to solve for time, you have to do so by first getting it out of the denominator and then dividing by your velocity. All right? So that is the way to get through this. I decided not to put the exact answers out there so that you guys still could get some credit if you turned it in. So if you have any questions or problems, please email me. Let me know as soon as you can, and I will try to help you out. Have a great day.